Hi guys, hope you had a good weekend and you took your test yesterday. Hopefully that went well. I just want to say right now, it's setting in. I'm missing you guys. I'm missing being at the school, and I know you guys are too. But hopefully we keep pressing on and get this term in and do the best we can. And anyway, hope you're enjoying the videos and that they're working for you. And there's going to be a little mix of me and then some online ones too, depending on the material. But we're going to start our new kind of unit at this point. We're going to move from angles. Now we're going to build into shapes now. And so, we've got the basic of the angles down. Now we're going to put some of those into the shapes and move on with some of our shapes that we got to get to. And the first shape we're going to work with has the word angle in it, but triangles. Okay? We're going to look at triangles. And triangles have a lot of special features about them. If you go further in math, trigonometry, it's triangle basically, and you deal a lot with that. But they have a lot of special features. But first we need to get the basics of them down, some of the rules about them. Some of them are really neat and you can use heavily in geometry, and so it's good to get those down and get a basics of them. And so the word tri, though, we use that word for three, like a tricycle has three wheels. Tricentennial is 300 years. So tri we use for three, and so that means this shape has three angles. Now I know we learned in grade school that triangles have three sides, and they do, but if you look at a triangle, they also have three angles. They have this angle here, they have this angle here, and they have this angle here. So they have three angles as well. So that's kind of where that builds. And triangles can look all different ways. You can have a triangle look like this, you can have one look like that. They can look all different. So we're going to kind of start in that realm of things. But first thing I want to lay out that's neat about a triangle is all the angles always add up to 180 degrees, just like the straight line is 180 degrees. In fact, you fold the three angles out, but you can do that with other shapes too. But basically, it's 180 degrees always for any kind of triangle, whether it was like that first one I drew or that second one. So we use that to our advantage here in a little bit to always find, well, what if we're missing an angle, we can fill in that missing angle based on this knowledge that all the angles add up to 180 degrees, okay? Quick example of one is if I have, let's say I have a 90 degree angle here and a 30 here, well, that's 120, and so we can know that this one needs, and I didn't draw it right, but we know that this then has to be a 60 degree angle, okay? Because they have to add up to 180. So 120 from 180 means that that's 60. And like I said, I drew it wrong, but that's because I'm not an art teacher, thankfully. I enjoy art. I enjoy looking at it. That's about my extent of what I can do with it. But basically, here is this knowledge right here. Now, the first thing too that I also want to look at is the names of triangles. We talk about names a lot in geometry, but the name of a triangle also helps into what kind of triangle it is and how to work with it and things we can do with it. First off, you can name a triangle by its angles, okay? So there's special things about their angles that you can name a triangle from. The three names that you can name a triangle by its angles is obtuse, acute, and right. Okay, obtuse, acute, right. And if you remember, we also use that name for angles. The angle was obtuse, or it was right, or it was acute. Well, it's the same thing with a triangle, but the first thing you got to realize is there's three angles in a triangle. So, like, what if one of them's obtuse and one is acute? Which one do you choose? And so this kind of goes into it here. First thing is, if a triangle has, let's say, an obtuse angle. I'm going to draw an obtuse triangle. And the only angle I'm going to put in here is right here, 100, we'll call it about 130. It looks to be about 130 degrees. Okay? And it has that obtuse angle. Okay? Well, it's also got two other angles that we can clearly see are going to be acute, less than 90. But we need to prove that. Why? Which kind of triangle then does it become? Do we choose? There's two acute, so does that mean it's acute? There's only one obtuse. Does it overrule the obtuse? What happens there? Well, if you think about it, if that's 130, or even if it was 91, just bigger than 90, and you took that away from here, so let's take 130 away from 80. There's only 50 degrees left to split up between these two angles. Meaning there's no way these two angles could also be obtuse. There's no way you could have it be obtuse. Even if I had the smallest obtuse angle you can have, which is 91, and I know it could be 90.1. We're not going to work with decimals here. But let's just say it's 91. Then right here is 89. You subtract that. There is no way you could have an obtuse triangle and have another obtuse triangle in the triangle. You would already be past 180. Just think about it. If you took 91 and the other smallest one, 91, you're already past 180. You don't even have room. You didn't have room for that one even, but you definitely don't have room for a third angle, okay, to fit into that 180. So a triangle can only have one obtuse angle in it. And if it's got that obtuse angle, then it is an obtuse triangle. So it just needs one obtuse angle. Okay? If it's got that one obtuse angle, it's an obtuse triangle. Okay? Same thing with a right. I'm going to skip forward and hit the right because it falls into that same category. If that's 90, okay, there's only one right angle in it. But if I put another 90 degree, okay, so let's say I have a 90 degree and put another 90 degree, well, there's no way those sides are ever going to meet and make a third, just be three sides. It's going to end up being four sides. And so if you have 90 and 90, you're already at 180. You don't have any room left for a third angle. So that means if you have one right, that's as many as you can have. And if you have that one right angle, then it is a right triangle. So all it needs is one right angle for it to be a right triangle, okay? It just needs one right angle, and it becomes a right triangle. Now what they're going to do, just to know as you go on and see geometry, they're not going to put a 90 to mark a right angle. They're going to put a little box here, okay? And we kind of did that with angles, but just know when they put that box there, that means it's a right angle. It's 90 degrees. Therefore, it's a right triangle. And we're going to really focus on right triangles in the next unit, or even in this unit some, but if I split it up in two. So right is 90 degrees, there's only one. That means acute has all three angles are acute. Because as soon as you have one that's obtuse, it becomes an obtuse triangle. As soon as you have one that's right, it becomes a right. So that means for it to be acute, all three angles are acute. And that, it can still look in different ways. You could have one look like this, 60, 60, 60. They're all acute. They're all less than 90. They add up to 180. But you could also have one be like, we'll call that 70, we'll call that 60, and we'll call that 50. So 130 plus 50 is 180. That's 180. They're all acute. They're all less than 90. So the triangle can look like that as well. You can have different looking triangles be acute. And same with obtuse. They can look different. Right can look different. Okay. But as soon as they have one right angle, they're right. As soon as one obtuse, they're obtuse. Okay. So that's naming triangles by their angles. Okay. You can also name triangles by their sides. And that's talking about their side lengths. So we're not talking about the angles anymore. We're talking about the length of their sides. If I've got a triangle here, and I don't know anything about the measurement of the angles, but I know this one's like 10 inches long, maybe this one's 12, and maybe this one's 15. And I know how long the sides are, then I can name the triangle by its sides, okay? By its side lengths. And so this triangle, okay, we can name it by its sides, and then as soon as we know about the angles, we can name it by its angles as well. Like if we later find out that this is a 30 and this is a 110 and this is the 40 then we can name it by its sides and we can name it by its angles, which it's obtuse. So it has both names, okay? But first off, naming by its sides is scalene, Okay, and these are weird. You may have seen the other ones in the prior thing, but these you probably haven't seen in a while. So you've got scalene, isosceles, and this one's always fun to spell. And I'm not cheating there. I'm just looking at, I'm looking at my paper that has the spelling on it. But anyway, isosceles and equilateral. Those are the three names for a triangle by its sides. All that means is scalene has no sides the same. So like that 10, 12, and 15 one. No sides of the same length. Okay. So there's no sides the same length. Okay. Isosceles means there's at least two sides the same length. So like you could have one be 8, 8, and 10. As long as two sides the same, at least. Okay, that means that's an isosceles. And then an equilateral is all the sides the same. Okay, as long as you remember that, it'll help you. Now technically, a technical thing is an equilateral can also be an isosceles because it's got at least two sides, it's got all three. But all that's for is later down the road. The properties that apply to this can also apply to this. But as long as you remember no sides the same as scalene, two sides the same as isosceles, and all three is an equilateral, that's what you need to know for this material. Okay, so that's the names, naming by its angles, naming by its sides. A couple examples that you could do. Like I said, let's say I've got a 90 here, and let's call it, let's 6, 8, and 10 it. 6, 8, 10. Okay, so here's the length of the sides. It's a right triangle because it's got one right angle. So I could name this a right triangle. So a right, and because none of the sides are the same length, it's a right scalene. It's both. We know about both. We know it's a right triangle from the one angle, and we know it's a scalene because none of the sides are the same. Okay, so that's a right scalene. Another example is you could have a, let's say that's 70, 70, 40, and let's say that's 9, 9, and 5. Okay, well, they're all acute. All the angles are acute, so it's an acute. And then there's two sides the same, so it's an isosceles. I don't even think I had to look at the paper to spell that right. Yeah, look at that. So an acute isosceles. Okay, so that's how you would name a triangle by its sides and its angles. Okay. The last thing that you can do for this assignment, and these parts, and we'll stop there, is find missing angles. And we did that just when I introduced the 180. But if I've got a triangle here, let's say that's 120 degrees, and let's say this one's 30. And let's put, because we put unknowns with a variable, let's put an X there. And let's say, let's just find that angle. What is that angle measure? Well, what you would do is add these two together. So 120 and 30 is 150. And take that away from 180. See what's left. Okay? So you have this angle is 30. Okay? X is 30 in this case. That's what you do. You find what the other angles are, subtract out, and find that. We'll stop there. We get a little bit further because we could start putting in other numbers than x, x minus 10 or something like that. And then we'll start even to like what happens if you know a linear pair, but there's two missing, working our way like a puzzle piece. But let's stop there and have you work from this point, from this basic material here. I'm going to put some ones up here for your assignment. So I want you to name these triangles by their sides and angles. So it's going to have two names for each one. Okay, number one, we got 3, 4, 5. Number 2, that one a ride. 120, 30, and 30, and 8, 8 and 15. Number 3. 80, 55, 45, 12, 10, 9. Okay, and these are the degree measures. These are the side leans. Okay. Number 4, I want you to name this one. It's a 60, 60, 60, and a 4, 4, 4. Okay, and then on these two, I want you to find the missing angle. So you're going to find the missing angle, and it'll be x. So you're going to solve for x. Okay. So this, we'll call this 110, 40, x, and on this one, we're going to put our little symbol here, and 50 and x. Now remember, I did give you two measurements. I know it doesn't look like it, but I gave you 2 measurements, so you got to find the third. Okay. All right. Thanks, guys.